Hello everyone, today we are going to talk about what is nitrogen. Okay, so nitrogen is a chemical element with symbol N and atomic number 7. Properties of nitrogen. Nitrogen is colorless, odorless, and tasteless. Nitrogen has a boiling point of negative 185.79 Celsius. It has a melting point of negative 210 degrees Celsius. Its nitrogen oxide compounds react with water to form soluble nitric acid. When heated, nitrogen reacts with magnesium, lithium, and calcium. Nitrogen combines with oxygen to produce nitrogen oxide in the presence of spark. Nitrogen is generally slightly soluble in water and inert. Uses of nitrogen. It is commonly used to form ammonia, which is NH3. The ammonia produced is used to make nitric acid fertilizers. Liquid nitrogen. Liquid nitrogen is usually used as a refrigerant for freezing transporting food products. Liquid nitrogen is also used as a blanketing gas to protect from flammable things. Effects of nitrogen. On the environment, when nitrogen is released during fuel combustion, it combines with oxygen atoms to form nitric oxide. Nitric oxide further combines with oxygen to form nitrogen dioxide. The oxides of nitrogen react to form smog and acid rain. On health, nitrite causes reactions with hemoglobin in the blood, causing the capacity to store oxygen to decrease. It decreases the function of the thyroid glands. Ammonia. Ammonia is a colorless gas with a pungent odor. Ammonia is lighter than air. It is collected by downward displacement of air. It is also highly soluble over water. Gas can't be collected over water. It can be liquefied at room temperature with 8 to 10 atmospheric pressure. Liquid ammonia boils at negative 33.5 Celsius under 1 atmospheric pressure. It freezes at negative 77.8 Celsius, giving a white crystalline structure. Chemical properties of ammonia. It has a chemical formula of NH3. It is a weak base and a strong reducing agent. It is quite reactive and it is in covalent molecules. What is Haber process? It is an industrial process to make ammonia from hydrogen and nitrogen. Hydrogen is from reacting natural gas such as methane and steam, and nitrogen is from the air. Process of Haber process. So this is a brief diagram of how Haber process is done. Firstly, nitrogen and hydrogen will undergo a process known as scrubbing, where all impurities are removed from the gases and they are purified. Number 2, the mixture is compressed to a pressure of 200 atm. As the particles gain more energy, it increases the temperature of the mix up to 300 degrees Celsius. This causes the hydrogen and nitrogen molecules to split up. Number 3, the converter is a tank heated to 450 degrees Celsius and is pressurized at 200 atm. Inside it, bits of hot iron acts as a catalyst to speed up the reaction but not participate in it. The N2 and H2 react at its surface to form ammonia. However, not all the H2 and N2 reacts together, and some of the ammonia undergoes forward reaction. As a result, only 15% of the mixture exiting the converter is ammonia. Number 4, the mixture of hydrogen, nitrogen, and ammonia are removed from the converter and cooled, and is collected. Ammonia is collected in tanks as a liquid and stored under pressure. Number 5. However, the nitrogen and hydrogen remain as gases. They have lower melting points. They are directed back into the converter for another chance to react. where step 3 and 4 is repeated. Equations. So these are the equations happening in the Haber process. The reaction is reversible and the production of ammonia is exothermic. Proportion of hydrogen and nitrogen. It is in the ratio of 1 to 3 due to the Avogadro's law. Equal volumes of gases contain equal number of moles. Nitrogen and hydrogen will react together under these conditions: a high temperature, about 400 to 450 degrees Celsius, a high pressure, about 200 atm, and with an ion catalyst. But why? A high temperature favors backward reaction, and this shifts the equilibrium to the right, which increases yield. It increases the rate of reaction and compromises 15% of ammonia made quickly. Number 2. A high pressure, about 200 atm. Higher pressure favors reaction with fewer molecules, and it also increases the yield of ammonia. Number 3. With the help of an ion catalyst, it increases the rate of reaction and it has no effect on equilibrium. With the absence of catalyst results in virtually no reaction. Potassium hydroxide is also added to increase efficiency. Economic considerations: high capital costs and high running costs. It is needed to build extremely strong pipes to withstand the high pressure. Next, we are going to talk about fertilizers and pK. What do fertilizers contain? Most fertilizers usually contains nitrogen, potassium, and phosphorus. A fertilizer. Earth's atmosphere is nearly 80% nitrogen. It must be in the form of other nitrogen compounds such as ammonium nitrate that is commonly used as nitrogen fertilizer. Uses of nitrogen. It promotes plant growth and vegetative growth. It defends against pests and forms chlorophyll. It also creates food for the plant through photosynthesis. A lack of nitrogen will cause chlorosis, which is the general yellowing of the plant. Positive effects. Nitrogen in fertilizers help plants thrive despite the threat of weeds and disease. Organic fertilizers such as manure improve the fertility of soil by feeding microorganisms in the soil, reducing erosion and keeping soil well hydrated. Negative effects. Excessive vegetative growth. Excess nitrogen in fertilizer can lead to excessive vegetative growth, flowering, and fruiting. Groundwater contamination. Rainwater carries excess nitrogen from fertilizers and is broken down into nitrates. Later immersed in the soil, it builds up over time and may lead to diseases when drinking water such as gastric and stomach cancer.